Good afternoon, everyone. Today we're going to start our discussion on a very important aspect or a very important topic in financial analytics. And that topic is called machine learning. Now, if you Google machine learning, you'll be deluged with so many references about it. Ang daming write-ups, many discussions about what machine learning is, what what's the importance of machine learning. So before we do our own machine learning algorithm tools, let's I identified some. These are sources that are really, let's say, very credible. So see, one of them is SAS Institute, Meet Sloan, IBM, and the Gartner reports. Now, may I ask who among you have made use of SAS before? SAS is a software, and this is a very powerful statistical software, and also a very powerful machine learning. Uh, it's a software also used in machine learning. Kindly chat, please, if you have, yeah, just yes or no. I just want to know who among you have been able to make use of the SAS as a software. Okay. Okay. Thank you. All right. So years ago, may SAS ang Lasal eh. I don't know what happened dun sa ano natin sa sa SAS natin. But anyway, so let me just share this with you. Itong first is SAS, and kindly open that site. Okay, so let's open that site, yung SAS site. Okay, here, this is SAS. Okay, so SAS class is a software, they provide software, and they are also a consultancy service provider. So ito yung software nila, isa sa pinaka ano yung SSS BIA. Okay, I have undergone some weeks of training on SAS BIA. Very powerful software. Tsaka ang ganda yun sa machine learning. So a lot of features, okay? And the solutions are used for fraud detection, Internet of Things, marketing, risk management, and for several industries, banking, public sector, etc. Okay, so let's just take a look at what's inside this one. So do you have this now, class, yung SAS site? Let's just take a look at this. Paki-chat na lang, please, if you have if you are able to open the site. All right, thank you so much. Good. Okay, so you have here some tabs here, today's world, who uses it, who uses SAS. Okay, so I'll go to this later. So let's go back here. And SAS gives us a pretty good definition of what ML is, machine learning. So it says here that machine learning is a method used in data analysis. So it helps in computing because it automates analytical model building. Actually, machine learning is part of AI. Okay, and in AI, it presupposes that the machine is able to learn. Technically, iba yung learning ng machines kaysa learning ng learning process ng human brain. Siyempre walang makaka-capture ng Although ngayon they say that mas powerful na mag-isip daw yung yung mga computers. That remains to be seen. Okay? So computing machines, quote unquote, learn through patterns. No? So they're able to identify patterns and make decisions. Ito importante dito, with minimal human intervention. Okay, so that's why ngayon meron tayong mga driverless cars, di ba? So ano yung ginagawa nun? They're able to identify patterns. For example, over on the left, may makikita siyang may magkocross na individual. So that pattern, that image is processed by the computer, and then it generates some decisions. For example, whether to stop, makakita ng stoplight, colored green, anong gagawin ng ng car na yan. So it's really to make decisions and real-time decisions. Kasi for example, if the machine that's making use of that is a car, no? A driverless car. Real time talaga yan. Dapat yung decision na gagawin. Okay, so this talks about basically the evolution, no? Evolution of machine learning. And ito yung some of the applications. Ito, I just said a while ago, yung self-driving Google car. And then you have here the mundane, the day-to-day things that we encounter. For example, nanonood ka ng TV, o you're going to buy from the internet, or sa Lazada. I'm not sure if Lazada makes use also of the recommender system, pero definitely si Netflix gumagamit nito. No wonder if you watch a movie, for example, nanood ka nung kay yung The Plane, no? Shot in Mindanao, na binan dito sa Philippines. So, if you watch that, notice that makakita ka ng recommendation sa baba, no? Kung ano ba yung mga movies na similar to that. Kasi movies are classified eh. Diba? Classified siya into horror or into animation or Korea, whatever, or action, drama, etc. Okay, so if you watch that, and if you have a pattern of watching that, then they will recommend other movies of the same genre. Ganon din si Amazon. When you buy from the net, you buy this item, buy this book, and it will give you some recommendations on books of that type. So, ang ano niya, recommender system siya, no? Recommendation algorithms making use of machine learning. So, yan yung mga mundane applications, no, sa daily life natin. So, ginagamit din yan sa text, sa linguistic rule creation sa Twitter. It's able to identify ano yung mga comments, no, ng mga customers about a particular, let's say, product. Ganun din sa TikTok, I think. Ginagamit din siya. And one of the most important applications of machine learning is sa banking and finance, fraud prevention. You know very well how prevalent this is now, yung fraud, yung scamming, yung mga scammers. Just this morning, I isang feed ng kaibigan ko na he has been duped of 75,000. 75,000. Ano rin yun parang so may binibili siya online. Tapos ang mali niya dapat either nakita niya muna yung product or dapat there has to be a way na makikita muna yung product or something like that. Siya nagtiwala na lang siya dun sa seller. So GCash. Tapos may time bank pa yata, no? So GoTime or something. Ayun, duped of 75,000. Wala na. Nawala na yung Facebook account ng So things like this, no? So importante yung machine learning, no? In this day and age. So this discusses why machine learning is important. Have you heard of the dati 4 Vs lang yun eh. Ngayon 6 Vs na yata of data. Anyone? Can you chat? Ano yung mga features ng data? Yung 4 Vs or 6 Vs? Letter V. And one please, pakicheck nga. Ito yung mga attributes ng data natin ngayon. What can we say about the data in this time and age? Can you check class sa internet yung 4 Vs of data? And again, as I said, 6 na nga yung update na nakita ko. Yeah, okay. Number 1, variety, no? Variety ng data. Data now comes in different shapes and sizes. Okay? Different shapes and sizes. May may numerical data, may numbers, may text, may pictures, may video. You go to TikTok, anong klaseng video doon? Anong data? Video 'yon, di ba? Reels. Yeah, thank you Patrice and thank you for the others, no? Yan, you're correct, no? Thank you Migs, uh, Jenica, etc. No? So to those who variety, volume, velocity, veracity. Ayan. Volume, velocity, variety, and velocity. Actually, may nadagdag pa dyan na dalawa pa. I think may value, tapos may may isa pang V. Velocity, yung speed by which data changes hands. Diba? Grabe yung volume ng data, velocity ng data, variety, and veracity, yung truthfulness. Ibig sabihin, you can check at any time kung totoo ba yung yung data na yan. Okay? So these are the things that describe the data of this day and age. So big data na talaga, no? Very huge amount of data. Hindi lang mga gigabyte, hindi lang mga terabyte, exabyte na. Okay? Do you know how big an exabyte is? Can you tell me, class? How big is an exabyte? Can anyone tell me? Tapos ano na yung biggest na metric ngayon ng bytes? When I used to be a student, hindi naman namin alam yung mga hindi naman pinag-uusapan yung mga gigabyte at saka terabyte eh. Bytes lang ng kilobytes lang naman at saka megabyte, no? Wala, naging ano din naman, naging gigabyte. So I used to have this 5 1/4 na floppy disk na ang laman lang niya 0.7 megabytes. So tuwa na ako nun. Tapos I would have this container na nakalagay yung mga floppy disk drive ko, yung 5 1/4 ba, 5 and a half. Tapos it can only store 0.7 megabytes of data, 700 something kilobytes of data. So masaya na kami noon, no? Tapos and then nag-introduce si IO ng isang big floppy disk, no? That can contain 100 megabytes of data. So grabe kasi yung maliit na disk 1.4 megabytes lang yun eh. Okay, so na-introduce yung 100 megabytes. I was so happy then already. Yan, may yottabyte pa, no? Okay, so these are now the metrics yan. May mga yan. So 1 billion gigabyte, okay, is the exabyte. Tapos may yottabyte, may zettabyte, okay? So yan ang mga metrics ngayon, class. That's how big data is. Yun ang volume ng data, no? So importante talaga yung mga machines, machine learning tools that can really accommodate yung mga data na to. Okay. So going down, ito daw yung mga gumagamit ng data, ng big data, ng machine learning pala, I'm sorry. Financial services, yung mga banks, which I mentioned a while ago, yung how to detect fraud, how to prevent this, cyber surveillance, okay? Government, healthcare, sa medicine, ginagamit na to in order to be able to predict kung magiging prone yung isang tao for cancer or not. No? Government, healthcare, oil and gas, etc. Transportation, yung sa isa, yung sinasabi kong driverless car. Okay, so a lot of applications. And here is some list of yung algorithms na ginagamit, no? Andiyan yung neural networks. Magkakaroon tayo ng example dito sa discussion natin ito. Later, not today, but later. So decision trees, ito yung di-discuss natin ngayon. These are the algorithms that's available in machine learning. No? Random forest. Hopefully we'll have the chance to discuss this SVM, support vector, nearest K neighbor, K means clustering, etc. Okay? And all right, so it's important for us to be well versed with the terminologies or yung lingo ng machine learning. So andiyan si supervised learning. Pag supervised learning kasi, labeled yung data natin. Okay? May label siya. Ibig sabihin, kunyari, you have data where andun yung classification kung yung tao, yung weight niya, no? So nakalagay weight, tapos andun yung weight niya, 130 pounds, etc., etc. Labeled yun, no? So that's supervised learning. Tapos kung walang mga labels yung data, that's unsupervised learning. Okay, then we have also semi-supervised and then reinforcement learning, which I'm not going to discuss. I'll leave you to look at these things. All right. So the issue here, class, is that ano na to, no? Punta natin isa muna, no? So from SAS, let's go to another one. Okay. Okay, dito muna tayo kay Gartner, no? So, si Gartner, I like yung, hindi, kasi kay MIT Sloan na muna. School to kasi, no? Control C. Let me share this with you. Okay, what does MIT Sloan tell us? So, andito ba siya? Hindi. Ito, MIT. So, let's take a look at, again, this site. Okay, this is MIT Sloan School, Massachusetts Institute of Technology. Isa sa top 5 schools sa US. So this is a good material kasi although 2021 pa to sinulat, ideas made to matter artificial intelligence. So ina-explain dito what machine learning is. So just like what yung SAS explained, pervasive and powerful form of artificial intelligence. So it's a game changer, class, to the industry, to any industry. Okay, and here, sa discussion na to, sa article na to, which I hope you're going to read, pinapakita niya yung advantages and limitations ng ML. Okay? So for example, ito sinabi niya, saan daw ginagamit, no? Nakita ko yung, I saw the term Netflix here. Sa isa yata yan. Okay, anyway, so dito, according to a Deloitte 2020 Deloitte survey, 67% of companies are now using machine learning. Okay? So marami na, hindi lang ito parang nice to have sa companies, hindi na. It's a must already. And then 97% in the next year daw, and 2020 survey ito, are planning to use it by the next year. So this is now a competitive, hindi na nga siya competitive advantage eh. Kasi when you say competitive advantage, it gives the company let's say a good advantage over their competitors. Pero hindi na kasi almost if everybody has it, then wala nang competitive advantage nun. It becomes now a competitive parity. So equal na. Ibig sabihin, kung wala kayo nun, wala, you'll be at a disadvantage, competitive disadvantage. Pag meron kayo nun, ano lang, equal lang kayo dun sa iba, no? Hindi na siya talagang competitive advantage. In the same manner, class, this goes for us as individuals. So since gamit na to, since this is already very important, I would like to encourage you to really hone your skills in this, in machine learning. So you might not have the facility for SAS. That's okay. Meron naman R at saka Python, which are now one of the highest used sa industry. Although SAS is a very powerful tool. Pero kasi ang mahal-mahal ng SAS eh. Millions yung SAS. Meron ka namang R system or Python na libre naman. So many are really migrating also to R and Python. So you're in good hands, class, kasi medyo may alam kayo sa R. Now, ang challenge ko sa inyo is to go also and move forward with Python. And it's really, for me, ang experience ko, so R muna natutunan ko. Tapos it was easy for me to migrate to Python. Madali sa akin matuto ng Python, having the training, having the knowledge of R. And ganun din sa inyo, class, yun ang masasabi ko sa inyo. So I would like to encourage you para malagay nyo rin sa ano nyo sa CV nyo na proficiency in R and Python. Malaking tulong yun later on. Okay? So remember, it's no longer a competitive advantage. Competitive parity na siya. In other words, pag marunong kayo ng R and Python, at least hindi kayo uh, you're not lagging, no? Lagging. You may not be at the forefront, pero hindi kayo nahuhuli. Okay? Kasi competitive parity na kasi, no? 'Di ba? Marami ng may alam 'yan. So, imagine kung hindi kayo nag-venture into learning Python also. So you will be overtaken by those who both know R and Python. So take the leap, everyone. I'd like to encourage you to do that, no? Take the leap and learn both. Sa ngayon, one software at a time, R muna tayo. And I hope we have planted the seeds of let's say passion here to learn. Okay? So sana class, when you leave the institution, you can put there in your CV na you're proficient in R and Python. Okay? So going down, ito nakalagay din dito, no? According to MIT, subfield siya ng artificial intelligence. Okay? So imitation, mimicking intelligent human behavior. Okay? It's used to perform complex tasks in a way that's similar to how humans, okay, yung thinking process ng humans. Okay, so there are different definitions here. And then ito, class, no? This is very important also for us to know yung functions of a machine learning system. So saan ba ginagamit tong let me just point this out. Machine learning starts with data. And sabi natin yung data, yung variety niya, no? You have numbers, photos, text, bank transactions, pictures, movies, no? Mga videos, even bakery items daw, repair records, etc. So all of these types of data are exposed to machine learning algorithms so that it will provide the company with better decision making. Okay, yun naman ang pinaka bottom line yan. You don't use machine learning just for the heck of it, no? Ito nga sabi, si machine learning, it doubles into descriptive. What has happened? Ano na nangyari sa company natin, no? What has happened in the past? So this is looking at the data of the past and then trying to see what has happened. And then prescriptive, no? What do we do now? Ito na yung anong gagawin, prescription. And then predictive, what might happen in the future. So it takes a look into the past, the present, and the future. Ganun yung ganun yung scope ng machine learning. Okay, dito may mga examples na magaganda, no? Algorithm try to generate recipes, no? Okay, ito imagine chocolate chicken cake. Imagine machine learning na nag-generate ng recipes. Can you dig that, no? Grabe, no? Okay, so ito yung mga functions na sinabi ko. Descriptive, okay? Explain the data to explain what happened. Predictive uses the data to predict what might happen. And prescriptive, the system will use the data to make suggestions about what actions to take. Okay, now, currently. All right, so this is just a repetition, yung supervised, unsupervised, reinforcement, semi-supervised. All right, so this is a good chart, no? On ano yung pwedeng gawin ng isang machine learning system. I'll leave you to peruse over that. Okay? All right, so ito may ano din, no? How businesses are using machine learning. Ito yung sinabi ko sa inyo kanina, yung recommendation system ni Netflix at saka ni Google. Right? So many things that you can learn here. And you know, class, it's important for you to be kept abreast with what's happening. So yung recommendation algorithms ang sinasabi ko. Okay, so it's important that you are aware of what's happening currently sa artificial intelligence, sa machine learning world. Now, finance tayo. So very, very ano sa atin to, very, very relevant to sa atin. And this is what I discussed a while ago, no? Ito nabanggit ko rin to. Ngayon, yung chatbots, no? Fraud detection. So a lot of applications for machine learning. Okay, and then here we have the promises and the challenges. All right, so I'll leave you to peruse over this. Basahin yung class on your own spare time. Okay, and then thirdly, ito pa rin si IBM, of course. Who does not know IBM? And then I'll just share also Gartner. Control C, chat natin. International Business Machines. Dati, number one producer ng ano to, ng computers, no? Ng laptops. Pero nag-ano na sila, iniba na nila yung focus sila. They're more on consulting now. Okay, so ano din to, discussion about what is ML. All right, machine learning versus deep learning. Unfortunately, hindi tayo makakapag-example ng deep learning, but neural networks, we will be able to have an example of that. Okay, so these are the different machine learning methods which I discussed a while ago. Andito si supervised, si unsupervised, no? All right. Okay, so I'll real world machine learning use cases. So what does this tell us? It tells us, class, that itong application ng machine learning is for real. Hindi lang siya something that's nice to know, nice to have. Companies are applying this. And not to apply this will be at your own risk. Okay? At your own risk to. All right. So lastly, yung last na I just chose 4. Ang dami-dami nito. I just chose 4 which I believe are very very sabihin natin ano, mga well-known institutions, well-known establishments. And let me just chat ko na rin din to, no? Si Gartner, no? I kind of like Gartner kasi si Gartner, ang daming researches nito eh. And marami silang research about the new trends, about how companies are making use of this. If you're really interested in knowing more about, not really the computing, no, but knowing more about the facts, about the challenges, about the ramifications of not being able to use machine learning, Gartner is the way to go. So ang dami nilang mga ano, ang dami nilang mga write-ups, ang dami nilang mga researches. So for example, 30 emerging technologies that will guide your business decisions. Rapid innovation is creating new possibilities. So let's take a look at the list dito. Okay. The Gartner Emerging Tech Impact Radar highlights the technologies and trends with the greatest potential to disrupt a broad cross-section of markets. Okay. As we know, yung rapid innovation ngayon, yung ng ng mga industries. Okay, so they're proposing this radar. Okay, I'll leave to you class to take a look at this. Okay? And tas dito naka-identify yung example, AI avatars. So ano yung mga digital twins? Okay, these are terminologies na it's important, class, for us to be aware of. Okay, maganda yung ano, yung alam din natin 'tong mga 'to. Especially later on, lalabas na kayo sa ano, sa inyong ano, some of you will be pursuing further studies. Okay? So kahit papaano sa discussion, nakakapag-ano din kayo, nakakapag-contribute din kayo. You're able to contribute because you are familiar with what's going on as far as this ML or AI is concerned. Okay, so very good site class itong Gartner. All right? So I hope I have encouraged you enough, okay, to really enhance, to really add more skills to your skill set, no? And you won't get wrong, class, kasi when you try to learn this, when you make it part of your skill set, you'll be encountering situations where this will become very useful. and you will be able to position yourself and market yourself more. Diba? Kasi maganda yung gano'n eh, because of your skill set. There is now a premium to what you can do, to your knowledge. Diba? So that's actually that's what we mean by monetizing your skills. No? Mino-monetize mo yung skills mo. In other words, you're putting a premium to your knowledge, to your skill set. Okay, so let's now with that class, let's go to our lesson for today. All right, and as I said, kindly load also tidyverse and party. We haven't encountered this package before, so try to check sa packages class, type party and then check if the party package is already installed and already loaded. And please chat if it's already done. Okay, thank you. Let's wait for the others. Okay, waiting for the others to be able to load yung party package. Okay, good. So let's give your classmates a few more seconds and then we proceed with our discussion. Okay, how about the others, please? Not half of the class have been able to do so. So I'm worried that I'll be continuing my discussion without with some of you not being able to follow along. All right, thank you so much. Okay, so let's just open party. This is not party, the party that we know. This has something to do with partitioning. Yeah, and so this is a laboratory for recursive partitioning. You may check the description file and try to see what this package is all about. You may go to the user guides or code demos here. All right, and then let's just go to the description file. So this was developed just last year, okay? No, not last year because I've been using this for uh, more than 2 years or 3 years anyway. So this is, I think, the latest version, 11 November 27, 2023. So that's 1.3-14. That's the version, and the authors are Thornsten, Hornick, Strobel, etc. So what is this all about? This is a computational toolbox. So this is used for machine learning for recursive partitioning. Okay, so used for classification. Okay, so you try to classify by splitting your data into different branches. So that's why this is called a partitioning, and this is used for decision trees. When you try to partition, okay, let me. So let's say you're trying to classify your data. So you have your data here, and then first you partition it into two, and then this one you can partition it more. This one you can still partition it maybe into three, into two. This one you can also partition, and this one also be like that. Okay, so it looks like an inverted tree. That's why this algorithm, this type of algorithm in machine learning is called decision tree. Okay, so we'll also discuss not only decision tree, But related to this is what we call a random forest. Kasi this decision tree, you have only one tree. For random forest, you have a forest of trees. So you have several of this. And that can really be very powerful. Okay. The objective is to try to come up with a classification. Okay. These are the outputs at the end. Okay. We'll have, you'll be able to see this in greater detail as we go along. There are many packages that's used for decision trees. We'll start with this one, the party package. All right. So let me share with you in the chat box. I'm going to share with you a file, a cardio file. So kindly, please load this, save this in your R project. Okay. So it's a CSV file, cardio CSV. Okay. And then let's load that. Okay. So here I created an object called cardio, and then we're using readr, and this is loaded already because of this tidyverse. Okay, tidyverse contains also this package, and then we're going to use the read_csv, and then we just identify the file name cardio.csv. No need to identify the location because I'll be assuming that you place this inside your files in your R project. So here, it's here inside my R project. Okay, machine learning decision tree. All right, so I'll be able to make use of the read_csv. Okay, all right, and please load this. Okay, let's download the cardio dataset, and then I'm going to view this. Okay, before I view it, okay, please chat if you are able to load the cardio dataset and tell me, class, if this you have this output 2,126 rows of observation and then 22 columns. Okay, good. So let's wait for the others. You should have been able to load your cardio dataset. Okay, how about the others? Just give your classmates a few more seconds. Okay. All right, thank you. I hope the others are able to follow. Okay, so the delimiter here is comma. This is a comma separated values. And then you have 22 columns. These are the names of the columns, LB, AC, FM. These are actually medical measures of the people. We don't need to really go into the nitty-gritty details of this because this is more of an example of health services. No? Okay, and then if we get the view of this file, so here we are. Okay, there are 2,126 observations and 22 entries, 22 columns, NSP, etc. Okay, what is of importance to us is NSP. Okay, but let's take a look first at the structure. Okay, what's the structure of cardio? So cardio has 22 columns, 22 variables, 2,126 rows. It's a data frame, okay? Special table. Okay, and these are the variables. So LB, that's pounds. So these are measures that's used by doctors. LB, AC, FM, they're all numeric, including the the last variable, which is NSP. This is numeric. So 2, 1, 1, etc. Okay, and then we can find here the columns. These are double, which means that these values are quantitative and they can take on decimal places, in contrast with the int integer. Okay, so that's our data. Now let's take a look. Let's take a look again at our cardio, and the nature of the last variable here, this NSP. This refers to yung N dito class is, sorry. Let me just write that. NSPN. NSP. This is actually the state of a person. So this is normal. This is suspect. And this is pathologic. So this is number 1. So number 1 means the person is normal. He has no heart condition. S is number 2, and it means that the person is suspect. He may or may not have, in other words, the findings of the doctors were not conclusive. Unlike this one, pathologic, which is number 3, and it means that the person has a heart condition. Okay, so this NSP actually is not numerical. It's actually a factor. So what's a factor? A factor is a variable, okay? It can take the form of a character variable or a numerical variable. Because for this one, for example, the number 2 here, we can replace it with the word suspect. Okay, and all the ones here, we can replace it with the word normal. And all the number 3s, we can replace it by pathologic. Okay, so a factor is a variable. It can be quantitative like this one. It can be categorical, if we replace this with normal, suspect, and pathologic, or it can be, okay, but whether it's numeric or whether it's a character, it can be used as a classifier. So in this case, normal, suspect, pathologic can be used as a classifier, just like year level, pros, sophomore, junior, just like gender, female, male, just like where were you born, Makati, San Juan, Manila, etc. So those can be treated as factors. Okay, now this is very important. Okay, so we will have to convert our NSP into a factor. Okay, there are several ways to do that. Let's go there. I'll clear the drawing first. Go here. Okay. Let me just close this. Okay, so how do we convert that NSP variable into a factor? As I said, let's first take a look at this one, NSP. What's the class of the NSP variable? It's numeric. Okay, it's numeric. Now we can use this. Okay, we can use this function, this code, cardio $NSPF. Okay, and then we're converting as that factor cardio NSP. Okay, so kindly tell me, class, what happens when we run this? When we run this, class, what happens? Okay, paki-chat, please. What happened to your cardio object, your cardio data set? May I have some feedback from you, class? Any feedback? When you run that cardio dollar NSPF, okay, actually you should be able to guess already what will happen, even without looking at the cardio data set here. But what's your answer, class? What happened to our cardio data set? Any chat from the class or any, you can unmute yourself. Yes, thank you. Let's see. All right. It became a factor. Cardio was converted to a factor. All right. This is jumping already, no? Pinying and Justin. I'm asking not what happened to NSP, but what happened to your cardio data set. So examine your cardio data set, and you should be able to already understand that because of this code. Okay, what's the new column, Migs? You can just unmute yourself, Migs.
Sir, yung NSPF po.
Yes, yeah, thank you. You're correct, no? Because here we're creating this object, right? This is the assignment operator, and we're telling R to create from in the cardio object $NSPF. This means this is not existent in non-existent in the cardio data set. So this means a creation. You're not overwriting something here, but you're creating something new. And then as that factor, cardio $NSP. So if you take a look at cardio here, I now have this NSPF and it's the same, okay? Only that NSP, what's the difference between this one? The difference between NSP and and okay, class, let me just copy this also. The difference between NSPF and NSP is that NSPF is a factor by virtue of this function as that factor, while NSP is numeric. Of course, class, we could have just deleted this, okay? We could have just overwritten NSP, and then as that factor NSP. Then that would have changed the class of NSP into a factor. But what we did here was to introduce this new column, this new variable NSPF. All right, let me pause for a while and ask your feedback. Are you able to follow so far, class? Okay, thank you. Thank you, Lee. Thank you, Eliza, Gwyneth. Thank you. Okay, thank you, everyone. Now, I'd like you to see the difference. No? If we, for example, I'm going to create a new code chunk. We can make use of the table function, and then let's see how the distribution of cardio and $NSP. Okay. What result do you get there, class? Table, cardio $NSP. Why is this in red? Table, NSP. There. What's the result, class? Anyone, please? What happened to your result here? class, what happened if I ask R to create a cross tabulation of what's inside NSP? Okay, so thank you, Jenica. Now, take note that NSP is numeric. Pero, yung numeric niya, 2, 1, 1, 3, etc. If I run this, let me go here first. Okay, summary ng cardio. You can see the difference. NSP will have its own, okay, NSP. It will have its own mean, median, okay, maximum value. While NSPF, since this is a factor, will have its own count. Si NSP dito, kasi ano siya, numerical class, so you can see the difference here. Now, a while ago, okay, for this one, okay, table, cardio, NSP. Good thing NSP class are whole numbers, so that if we run this, it will tell us that there were 1655 ones, 295 2, and 176 3. So there were more who were normal. Okay, so you get the same answer. Kasi nagkataon class that NSP has whole numbers. But if you were creating a table for one that has decimals, the answer will be very different. No? So here, same thing. So even if NSP is numeric here, it just so happened na yung ano niya, yung mga values are full numbers. No? Kaya nakapag-cross tabulation pa rin siya. Okay? All right. So at least aware tayo that in our data set of 2,126 observations, 1,655 are normal, 295 were diagnosed as a suspect, and 3 were pathologic. All right. So one thing very important as far as machine learning is concerned is that even if we have a huge data, well, relatively okay yung data natin kasi 2,126 observations. Now, what we're going to do is we're going to create a decision tree, the one that I told you a while ago. No? Decision tree to predict our data, 2,126 observations. So we'd like to see if we have a decision tree and then you compare this parang prediction class or regression. No? We're going to compare this with the actual value. Actual, compare natin siya sa predicted. Of course, we would want as much as possible that the predicted should be equal to actual. All right, now, in cases like this in machine learning, we do not use all the 2,126 observations to model because you will have what we call overfitting. Okay? Ayaw natin yung overfitting kasi what happens is that you use all of this, baka naman yung model na makikreate mo is really parang naka-fine-tune na siya for these 2,126 observations. So that if a new data comes along, tapos i-test natin yung data na yun, medyo hindi na siya magandang output because of overfitting. Nag-overfit tayo. Ginamit natin lahat ng data natin to model. So, how do we address that? Ang ginagawa natin dyan, class, is we partition the data. Kaya nga itong party, di ba? Yung party package. We partition the data. Okay? Ibig sabihin, i-split natin siya. Sometimes into 3, but mostly into 2. Ano yung dalawang split na to? We will have what we call a training data set and a testing data set. So how is this done? Okay? So we get a proportion out of this, a certain percentage, and then build a model using the trained data set. After we have created the model, ang gagawin natin, gagamitin natin testing data set in our model and try to see how our model performs with the data that it has not yet seen. Hindi pa niya nakikita yung data na to. Remember, these are all coming from 2,126, pero i-split natin data natin. Ipapartition natin. One will be trained and we'll be able to generate a model out of this. Okay? Yung model na to, class, gagamitin natin para sa testing dataset natin. And then see if tama din yung prediction ni testing dataset. Titingnan natin kung ilang percentage yung tama sa testing dataset natin to see if our model works. Okay? If our model works with another dataset na hindi pa niya na-meet. Okay? So kindly chat please if this concept is clear, class. Yung concept ng overfitting, yung concept ng partitioning the data into training, into testing. Yung iba, tatlo pa nga eh. Okay, may tatlo pang ginagawa nilang partitioning. But for our purposes, we'll just use two. Yung common naman yung two eh. Okay, kindly chat please if that discussion is clear. Clear ba so far, class? Let's have a quicker response time kasi medyo we're running out of time. We would like to be at pace with the other section. Okay. All right. So thank you so much. Okay. Now, how do we partition our data? And na-mention ko to, no? Overfitting. All right. How do we partition our data? First of all, magre-create tayo ng randomly generated na partitioning. Okay? So, yan ang purpose ng set.seed, which we already discussed before. No? Si set.seed will make sure that the randomly generated natin na partitioning will be the same. Okay? Para masusundan nyo yung ginagawa ko, we'll have the same answer. No? Kasi pare-pareho yung random generation natin. All right. Now, let's take a look at this function, sample. Okay? Sample, no? So this comes from a question mark, which means help function to, no? All right. So this comes from the base package. Okay. So in general, sample function takes a sample of the specified size from the elements of X using either with or without replacement. So this is very important. So ito yung syntax niya. Sample X, size, replace is equal to false, which is the default, no? So ibig sabihin nito, pag hindi natin linagay ito, so medyo iba to kasi usually yung true yung yung default eh. If we don't put this class, replace is equal to false, ibig sabihin nun, walang replacement, no? Okay? Kasi default yan eh. And then probability is equal to null, default din yan. Now, let's take a look at an example. No? So, dinidefine dito kung ano yung X, kung ano yung N. I leave that for you to read on. So, kumuha lang tayo example dito. Okay, so dito sinasabi, X, 1 to 12. So, random permutation, sample X, mag-generate siya ng 1 to 12, pero iba-iba yung order. No? Okay, kunyari, ito magagamit to if you have a class of, let's say, 20 students kayo. Kunyari, Control C, I'll copy this. And, sorry. Okay, copy ko dito, Control V. Alright, so kunyari, kayo, no? 12 students kayo. Tapos gusto ko mag-sample ng, kukunin ko isa-isa, no? Kukunin ko isa-isa yung, kunyari, ito yung class number nyo, 1 to 12. So if I'm going to get that, alright, so una si 10, si 2, si 8, si 12, si 5. So randomly generated to. Okay? So, ano din, no? Kayo, if you do this, you'll generate a random sampling, pero hindi tayo magkakapareho kasi hindi tayo nag-set.seed. Okay? So, yun lang ginagawa nitong sample. And there are many other many other things that we can do with this one. Okay. So, last example before we go to our example. Ito, no? Let's see. May isa pang example dito. Okay, ito na lang. No? Okay, yung isa na lang ulit. Here. Okay, so ang gagawin natin kasi class, yung data set natin, iba 2,126 observations tayo, no? Observation 1, 2, 3, 4. Ito yung index natin, no? Yan. So, 2,126 observations, ang gagawin natin, split natin siya into 2. Okay? So, paano natin i-split siya randomly? So, pwede tayo mag-create ng 2 groups, 1 and 2. Okay, so magpapakreate tayo ng 2,126 na ones and twos. Okay, so kunyari, nag-create si R ng 1, 1, 1, 2, 1, 1, 1, 1, 1, 2, okay, etc. So, ibig sabihin, itong first observation, 1. Itong second observation, 1. Third observation, 1. Fourth observation, 2. Okay, etc. So, ang mangyayari ngayon, ang splitting ngayon, lahat ng 1 pupunta sa training group, lahat ng 2 pupunta sa testing group. Right? So, ganun lang, kasimple, no? It's that simple. Okay? So for example, okay, mag-create tayo no ng sample ng 2. Pag sinabing sample 2, dalawa. So that means 1 and 2 na kagad yun, no? 1 and 2. And then ilang number of times natin ano yun? 2, 1, 2, 6, di ba? Magpapakreate tayo ng object na 1 and 2, 1, 1, 1, 2, 2, 2, 2. Ilan siya? 2,126. Alright? If I run this class, okay, mag-e-error. Mag-e-error. Kasi, bakit nag-error? Kasi, annotate natin, no? Ito yung ano natin. Imagine a container. Tapos, andyan may dalawang ping-pong balls. May isang 1, may isang 2. So, ang gagawin natin, magdo-draw out tayo. I-draw out natin si 1. Okay? Hinalo muna natin. Tapos, mag-draw out tayo kahit anong sa kanila makukuha, no? So, kunyari 1. Okay? So, si 1 nakuha na. So, ibig sabihin, yung first observation natin, 1 yon. Okay. So, ilan na lang matitira dito? Si 2 na lang. Diba? So, kung next round, kinuha ko pa si 2, di wala na matitira. Wala na laman yung ano natin, container natin. Kaya nag-error siya dito. So, dapat, may adjustment na gagawin tayo dito. Kasi ang default nito, replace is equal to false. Diba? Sabi ko kanina, no? Yan ang default niyan. So, ibig sabihin, pag rino out natin dito yung 1 at saka rino out natin yung 2, hindi na ibabalik yan. So, dapat palitan natin to. Dapat gawin natin replace is equal to true. What does that mean? Unang kuha, no? Natin, hinalo. And then, we got one number here. And then, we should bring it back. Okay? And then, get another one, bring it back. Okay, so even if we draw out 2,126 from this container, okay lang, no? It will be okay because you still have the same 1 and 2 here. Okay, because we said replace is equal to true. You have to put back what we initially got. All right, so that's what the replace, that's why that's very important, no? Okay, so let's go to our function. Okay, we need to create a vector of numbers. So take a look at this code, class. So sample, okay, sample 2. So it means it will choose from 1 and 2. Or you can also do this 1 to 2, but that's obvious. Okay, 1 to 2. Or just 2, which means it will include also 1. All right, and then how many times? I don't want to put here the 2126. So n row cardio, you know what this means? The number of rows of cardio, which is 2126, which is good practice because if you change the cardio data set, okay, and if it has a different number of rows, the 2126 will fail, but this one will be okay. All right, and then here, this is what I was saying. Replace is equal to true. We have to put that here. Otherwise, if we don't put it here, the default is replace is equal to false. So this will generate an error term. And then this one, class. Okay, so this will give us the distribution. So since this is probability, it tells us that around 80% will be for the first one. The first one is 1. And the next one is 20% for the second one, which is 2. Now, why is it 80-20? Because usually what we do is that for the training data set, it will have a higher number of observations compared to the testing data set. So sometimes you'll see 70%, 30%, that can be a combination, or 75, 25, okay, or 80-20. It really depends on the purpose, and it really depends on the size. So this one to 126, so around 80% of that is around 1,700. That's fine. And of course, 2-1, so around 400 for the testing data set. So that's fine. That's okay. The sample size for training, 1717, is okay. For testing, it's around 400. That's okay. Or you can do 70%. Okay, so that would also be fine. So whether it's 70-30, 75-25, 80-20, okay, it depends on the one doing the analysis. All right. But if it's fewer, class, so that has to be taken into deep consideration, especially if your number of observations is quite small. Okay, because you cannot afford also having a few observations for the test data. Okay, so take a look at this again. We're creating this object PD. Okay, it's sample. Okay, so sample of what? 2. It means 1 and 2. All right, so it will now generate a vector containing 1 and 2. How many? 2,126. Will this be possible? Yes, because if you get 1, we're going to put it back. If you get 2, we're still going to put it back. Okay, so we can draw out from the sample of 1 and 2. And then probability 80% will be for the first one. The first one here, 1 and 2, is 1. So that will be our training. And the next one, 2, is our testing. That will be around 80%. Okay, so let's run this, class. So this will now generate, and make sure we have the same set.seed. Okay, so that we have the same observations. I'll just comment this out so that it will not run anymore. So let me run this first. Set.seed, and then the sample. All right, please tell me what happened. Where will it fall under, the data or the values in your environment, class? Kindly chat, please. All right, it will fall under the value. So it's a vector, class, no? It's not a data frame. So it's only one row, 1, 1, 1, 2. See this, class? And if we print this, let's print this PD and see what it contains. There. So you now have PD, which is 2,126 observations, right? So it's an observations of, we have 1s and 2s. So we can now use this PD in order to subset our cardio data set. So we will put all the ones we will put to a training data set, and all the 2s, the number 2, to testing data set. Okay, so which means the first observation will go to training, and then this one will be for testing. Training, etc. So you notice that there are more ones than 2s, of course, because of the proportion 80%, 20%. Okay, and maybe a question to ask is, why not just for the first 1,700 observations, put it to training, okay, and the rest put it to testing? Okay, that can be done. That can be done, class. However, there's a danger there. In particular, especially if, let's say, you don't know how NSP or NSPF was arranged. So it's possible that NSPF was arranged all ones first. Then if it's all ones, then you will now have a split data where for the training, it's mostly number 1. and that will not be good. That will not be good. Okay? Because already we know that there are really more number ones, right? 1,700 plus. Where's this one? 1,655, 295. So if there are only 1,655 number ones, and then we'll split it at 1,700, and the data was arranged in such a way that it was chronological arranged at NSPF, all the ones first, then all the one will now go to our training data set. Wala na matitira dun sa testing data set. Okay, so that's the importance where it should be randomized. Okay, and the sample function allows us to do that. All right, so let's now split our data. We haven't split our data yet. Okay, so this one, take a look at this. I'm now creating the train data set and train, and then cardio, and then this one, subset, all the PD is equal to 1. Okay, so from the cardio data set, interpose it with the PD data set, and then lahat ng 1 pupunta kay train data set. All right, so let's run this. Run this. Okay, and let's see what train data set has. Okay, now it has 1,718 observations. Okay, it's not exact, okay, kasi yung 80% ng enrow ng cardio, di ba? This is 2126, right? 80% of that is around 17, okay? 1,700. So it's not really exact na 80%, no? So it's a probability. So our training data set has 1,718 observations. So all the number 5 a while ago, yung sa PD natin, di ba? Yung number 5 nun is number 2, yan, no? 1, 2, 3, 4, 5. Itong 5th observation class, mapupunta na yan kay testing. So how do you get the testing data set? Ito, naman. Create test data set. So it will be test is cardio, and then PD is equal to 2. There. So if I run this, so I now have my test data set here, and there are 400 observations. Okay, so if I take a look at my train data set, 1,718, my test data set is 408, and then if you add that, that's 2,126 observations all in all. Okay, so we were able now to split our data set using the sample function. Okay, so in the other section, they asked me, what if there were 3 groups? Okay lang, no problem, class. So ang mangyayari dito, magiging sample 3, no? However, your probability will now be C, kunyari 0.6, 0.3, 0.1, tatlo na. No? Kasi you have now 3 groups. Okay, or 1/3, 1/3, 1/3, equally, equal yung distribution. Okay, so as many samples you can have. All right, so let me pause for a while and ask you, so far clear ba tayo, class? Are you able to follow? Were you able to generate the train data set and the testing data set? Let's wait for your feedback. It's almost time. I'll just wind up with some of these things here. Okay, good. Thank you so much for your feedback. Okay, so what will now happen? All right, ito na yung class, no? Next meeting, we're now going to use the party. Okay, so let me just briefly describe to you what this is. So here I'm creating an object called tree, and I'm using this classification tree function from the party package. This is one of the most important function here, the party partitioning package. So what am I doing here? I'm creating, okay, so usually some machine learning, in machine learning, we also have what we call the cart. Okay, so this is classification and regression trees. So decision tree is an example of a cart model, a decision tree. Cart model siya because we are classifying. Okay, so let me just run this, but we will we will really discuss this in greater detail next meeting, but let me just show you. So I'm using the C3 function, and then I'm regressing NSPF associated with, we will just be using the three variables, the LB, AC, and FM. Of course, you can use more than this, but in order to just simplify our discussion. And the data is equal to train. Now take note, I'm using the train data set because we're going to create a model using the train data set. So if I run this, okay, now we have a tree, okay? So this is a large binary tree. So this is a list. And ang laman niya, class, yan. Maraming laman siya, no? Three, so it's more of a list. Okay. Then if I have this tree printed, and I'll end in this is what happens. Okay. So we have this strange diagram, no? We have this strange diagram telling us that there are 10 terminal nodes. Okay. The response variable is NSPF. The inputs are LB, AC, and FM. These are the independent variables that we're considering. Number of observations is 17, 18. Okay. So we have here a tree-like diagram. Okay, but it's difficult to understand that. So I'm going to make use of another function. This one, I'm going to have this plotted. Okay. So this one, plot the object Tree1. And then there you go. So this is our first decision tree. There. So next meeting class, we're going to discuss this. Ano to? So essentially, the model created an algorithm whereby we will be able to predict if a person is N or S or P, or normal, suspect, or pathologic. I can use this. Type is equal to simple. There you go. So this is our first machine learning algorithm. And this is a decision tree. If you follow the branches, okay, you'll be able to, let me just quickly discuss this. Sorry. Okay. So what does this say here? Okay. If AC is less than 0.001, so AC has a value. If it's less than 0.001, then you go to LB. Take a look at LB. Okay. And it tells us that if LB has a certain value, okay, then you go here. It's now classified. So this now tells us how the classification takes place. So these are your decision rules. And then these ones are your terminal nodes. Okay, it tells us what or how was the classification made. Okay, so we'll discuss this in greater detail next meeting. So this is now your first decision tree. So it now tells you why it's called a decision tree. It's called a tree, okay, and you follow the branches and you come up with a certain decision. Okay, all right, so with that class, we end our class for today. Let me stop recording.